Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the Number Theory and Abstract Algebra chapter, and this is question number 9. This question asks us, how many subgroups does the group Z3 plus Z16 have? And I'll just remind you that Z3 plus Z16, this is the direct sum of Z3 and Z16. In other words, it's all the pairs of the form AB, where A is a member of Z3 and B is a member of Z16. So, for example, 215, that's an element of Z3 plus Z16. Now, you have to remember a couple things to solve this problem. The first thing you have to remember is that Z3 plus Z16, all these Z's, they're abelian. In other words, they're commutative. And you also have to remember that an abelian group must have a subgroup for each number that divides the order of the group. What does that mean? If I have an abelian group like Z16, then I need to have subgroups of orders 1, 2, 4, 8, and 16. Okay. Now the question is, what's the order of Z3 plus Z16? Well, since 3 and 16 are relatively prime, actually it doesn't even matter that they're relatively prime. Any direct sum or direct product of two groups like that, the order will be the product of the number of the orders of each of the groups. So Z3 has 3 elements, Z16 has 16 elements, so Z3 plus Z16 has 48 elements. So the question is, how many numbers divide 48? How many numbers between 0 and 47 divide 48, or between 1 and 48 divide 48? And, well, the way to figure that out is one way is to write the prime factorization of 48. Well, that's going to be 2 to the 4th, that's 16 times 3. So any factor of 48 is going to be some power of 2 times some power of 3. Well, some power between 0 and 4 of 2, and some power between 0 and 1 of 3. Well, there's 5 options here, 0, 1, 2, 3, and 4, and there's 2 options here, so that's 10. You can check, there's actually 10 divisors of 48. So the answer is that there have to be 10 subgroups of Z3 plus Z16.